Hello, everybody. I hope you're enjoying your day so far and you're having a good morning. Unfortunately, I'm going to be out the rest of this week. So we're just going to kind of roll with this until I get back. Like I said before, I will answer any questions when I return. Hopefully, that will be on Monday, but I will keep you guys posted. So today, we are going to pick up where we left off talking about properties of logarithms. Yesterday, we looked at how to expand or condense them using properties of logarithms. Today, what we're going to talk about are the different ways we can change the base of logarithms. So when we first learned about logarithms, we talked about the two most common ones were common base, which is base 10, and natural log, which is base e. And then we looked at some different ways to evaluate logs that had different bases. Um, a lot of times when we have them, they're not always going to be those nice bases like base e or base 10. So what we're going to talk about is how you can kind of change those, because hopefully you've noticed sometimes if your calculators are in press to test mode, you can't exactly type in a base when you hit the log button. And so we're going to talk about how you can kind of get around that. And then we're going to use that later on to talk about some transformations. So what we're going to talk about is how we can change log expressions first by using what we learned as far as rewriting this in exponential form. So looking back to what we looked at before break, remember we talked about how you could rewrite an expression like this. I think at the time we had them more written as log base 4 of 7 is equal to y. We had it as x before, but same difference. And remember what we talked about is your base becomes your number. That number on the opposite side, or in this case, our y, becomes our exponent, and then that number inside goes on the other side. So we talked about how we can do that, and we can rewrite it like that. We solved things like this before break, where we looked at this. Remember, in order to pull that y down, we took the log of both sides, so that way we could put our exponent out in front. And that's how we solved logs algebraically right before break when we were looking at those. So what I can do is I can take the log of both sides, and that's going to move that y out in front. So this would become y log of 4 equals the log of 7. From there, if I'm trying to solve for y, then my next step is going to be to divide by that log of 4. So we know that y is equal to the log of 7 over log of 4. And since we're writing this without a base, it's really just base 10. Now, because this is base 10, you can type that into your calculator to get an approximation of that. That would be approximately 1.4037 if you were to type that into your calculator. Again, I apologize for the not great handwriting. I'm doing my best. But that really gives us kind of this idea of how we can change the base on any logs. And we're going to use that to kind of write these general forms. And there's two different ways we can do it. It depends on whether you want to work with log base 10 or natural log. Either way, the same rules apply. So in this next thing, we're going to talk about the two different base formulas you could use. So we could use, if we're changing to common log, just like we did there, if we had something that was log of some base, again, it doesn't matter what the base is, and then we had some number in there. The way we would change this, kind of like up above, looking at that placement, we can see that that 7, which is my x in this case, went up top. So we could rewrite this as the log of whatever you're taking, so in this case x, divided by the log of the base. Up top with that one there, we saw that our denominator was log of 4, our base was 4. So that's kind of where that idea comes from. So anytime you're trying to change your base, it's going to be the log of whatever you're taking the log of divided by the log of your base. So a good way to remember that is the base always goes on the bottom. Similarly, if you want to change it with natural logs, we could rewrite, if we have log base b of x, it would be the natural log of x over the natural log of b. So again, your base always goes on the bottom no matter what. So down here on number 5, we've got a couple different questions that involve practicing this. Two of them I'm going to kind of give you practice doing that way, and then I'm going to talk about one where we're not going to approximate it because you actually can get an exact value, and it's going to use those properties we just talked about. So let's go through question number 5. Okay. So I'll do one with log base 10 and one with natural log just so we can practice. I don't care which one you use. They will give you the exact same answer. If you don't believe me, change out log and natural log and type it into your calculator and you should get the same values. So with this one, if I have log base 3 of 16, like I said, the base goes in the bottom. So the denominator would be the log of 3, which means log of that number goes up top. So log of 16. You would type this into your calculator exactly like that. Use base 10, type in log of 16 divided by the log of 3, and you would get that it is approximately 2.5237. Okay, so when you're trying to change the values there, that's one way to do it. Let's do another one with letter B. I'm going to also actually use log for this one because this one, another cool thing happens. So if I rewrite this, I've got log base 6 of 10. So this would become log of 10 divided by log of 6. Now, remember, if we don't have any base written, this is base 10. So I'm really talking about log base 10 of 10. If you remember from the rules we talked about before break, that would really just become 1. So this is really 1 over the log of 6, which is a little bit nicer to type in your calculator. You could type it in either way. Just wanted to remind you of that. Either way, when you do that, you get that this becomes approximately 1.2851. Okay, so that's just some practice with using those change of base rules using log base 10. Now with letter C, let's go through and we're going to use natural log. And like I said, we're going to do this entire one out by hand because this does become a nice value and I'm going to show you why. So with this one, same idea. We're going to follow those same rules, except like I said, I'm going to use natural log. It would happen even if this was log, but let's practice with natural log. So this would be the natural log of 2 over the natural log of 1/2. Now, I can't do much with that numerator. That numerator is going to stay with me through most of this problem. But in my denominator, I do have division inside my log, and that goes back to those rules that we learned yesterday. So that would be the quotient rule. So remember, if I have the quotient inside of a log, I can separate it into 2 separate logs, putting subtraction in between them. So this becomes the natural log of 2 over the natural log of 1 minus the natural log of 2. So from there, this does simplify quite nicely. And the reason I want to talk about this is this is going to come up a whole bunch in a moment when we start working with some variables. But the natural log of 1, I'll write this off to the side. The natural log of 1 is equal to 0. Okay, if you don't believe me, type it into your calculator. So anytime you're taking the log of 1, that's always going to be the case. Because remember, anything raised to the 0 power is equal to 1. So when you're taking the log or natural log of 1, it's always going to be 0. What's nice about that is that natural log of 1 now in our denominator cancels out. And I get the natural log of 2 over 0 minus the natural log of 2. Now, you don't necessarily have to write that 0. So if I were to simplify that, that becomes the natural log of 2 over the negative natural log of 2. I've got the natural log of 2 up top. And in my denominator, when you divide those things, they're really going to cancel out, and I'm just left with that negative. So my final answer here is going to be -1. Now, like we did with A and B, you really could type things into your calculator. I was just showing you that breakdown because it's about to become important. So if you're asked to find exact values, you can write that change of base formula and then just type it into your calculator to give you those values. Okay. The last thing I want to talk about involving our change of base is how to use one kind of like that last one to talk about transformations on our graphs. So, same idea as before. I'm just going to rewrite those change of base rules. Specifically, I'm going to talk about natural log because that's really when this is going to come into play a lot. And I'm going to star this because I promise you this comes up a whole lot and we always forget how to do it in the future. So, I'm going to rewrite that change of base formula from up above. So that would just be log base b of x is equal to the natural log of x over the natural log of b. And now I kind of want to talk about how I can simplify this a bit. So right now I have a fraction, I have division. What is going to happen anytime you're asked about these transformations is you're going to be asked about how it transforms the graph of the natural log of x. So I kind of want to isolate that, and the way I'm going to do that is separate my fraction. So I can do that by writing that this is equal to my numerator times 1 over my denominator. Okay, so you can always rewrite it that way. Those are interchangeable. So if you wanted to write it the other way, you could also write it as 1 over the natural log of b times the natural log of x. Multiplication is commutative, so it doesn't really matter which way you write it as long as you write it one of those ways. And this is going to become really important when we have questions like number 6. So the very last thing we're going to talk about today is how we can transform the graphs of, like I said, the natural log of x from these functions that were given. And that all comes down to your change of base formula because it's going to show you your transformations. So we're going to practice using that a little bit here. So my first one with number 6, I've got log base 5 of x. In order to find my transformations, I want to change this into natural log. So I'm going to rewrite this as log base 5 of x. Using that change of base formula, it becomes the natural log of x over the natural log of 5. I'm going to separate these out and it'll make it a little bit easier to see the transformation. So I'm going to do this as my denominator first. So 1 over the natural log of 5 times the natural log of x. So when we do that, the key thing here is going to be this very important piece here in which I've got this out in front, that 1 over that natural log of 5 that's being multiplied by my entire function. So going back to what we learned about transformations before, if my entire function is being multiplied by a number, it's going to be a vertical stretch or a shrink. Either way, it's vertical because it's being multiplied by my entire function. In this case, and pretty much anytime you have ones like this, it's going to be a shrink. The natural log of a number is going to be bigger than 1. So in this case, our transformation is a vertical shrink by 1 over the natural log of 5. Okay, so that's how you're going to determine your transformations. You're going to rewrite it using your change of base formulas and then evaluate your transformations. It's always going to basically be 1 or 2 transformations based on the function for the most part. So in this case, it usually involves a vertical shrink of some kind. Now let's talk about what happens. It gets a little bit more complex when you have some fractional base. So looking at this one here, I have a fraction for my base in letter B. So I have to be a little bit more careful with this. It's going to be a little bit more complex and involve a few more steps. But I'm going to still follow the same idea from right there. So I'm going to rewrite my thing using my change of base formula. So the natural log of x over the natural log of 1/4. Like what you just did in A, I'm going to rewrite it as 1 over my denominator. So 1 over the natural log of 1/4 times the natural log of x, which was my numerator. And the reason this gets a little bit more complex or involves more steps is that natural log of 1/4 in the denominator, which is why I did 5c that way, because we just reviewed that rule. When you've got division inside a log, we can separate it using subtraction. So I'm going to do that here. So this becomes 1 over the natural log of 1 minus the natural log of 4 times my natural log of x. And our last step to simplifying that, again, is something I used in 5c. That natural log of 1 is 0, so it kind of cancels out. So I'm going to cancel it there. And this just becomes 1 over the negative natural log of 4 times the natural log of x. Now I want you guys to be careful because this happens all the time, is that we like to include this negative here in our vertical shrink. A negative does not indicate a vertical stretch or shrink or a horizontal one. It really involves a separate transformation. If I have a negative out in front of my entire transformation, that is a reflection over the x-axis. So that gives us my first transformation, and that second one is going to again be that vertical shrink. So here our transformations are a reflection over the x-axis. That negative gives us that, and our second transformation is a vertical shrink of 1 over the natural log of 4. Okay, so please, please, please be careful that negative should never be involved in any sort of stretch or shrink, whether it be vertical or horizontal. All right, so that is it for notes today. You should be able to finish up the entire rest of the homework. I believe that would be questions 13 through 20 in the property of logs. You have the remainder of class to do that. If you have any questions that are urgent or pressing, please, please, please feel free to email me. I am checking my email very regularly. I can't wait to see you guys soon. Like I said, please feel free to reach out if you're confused or have any questions. Have a wonderful rest of your day.